everyone, my name is Talia Chen. I'm in ninth grade at the Buckley School. This is Curio Crate, and today we're going to be learning about how do electric circuits work? Well, here's the science behind it. Let's first define electricity. Electricity is a form of energy that moves. Electricity is made up of tiny particles called electrons that move from one place to another. Electricity flows through wires using these electrons. So here's a real life example. Imagine you and your classmates are passing a ball in a line. This ball is like how energy is passed along through wires. And here's a fun fact. Electricity moves almost as fast as the speed of light. Now that we're talking about electricity and we're talking about electric circuits in today's video, what is a circuit? Well, a circuit is a loop that lets electricity flow all the way around the loop, as shown here. But if this loop is open or broken in some shape or form, the electricity stops flowing. Now, here are the parts of a circuit. First, we have the battery. The battery gives the energy that makes electricity start moving in a circuit by pushing it through the circuit. And a battery is like a power station. It has two ends, positive and negative. And here's a fun fact about batteries. A AA battery can push electricity through about 5 feet of wire. Now, what are wires? Well, wires carry the electricity. They are like roads or highways that electricity can travel on, and they connect every part of a circuit together, like from a battery to a light bulb. Now, inside these wires are metals like copper, shown at the end, that let electricity flow very easily. And if electricity flows very easily, this means that they are great conductors of electricity. Now, outside this wire is usually a plastic cover that keeps electricity safe inside and protects us from electric shock. Now, what is a load? So a load is something that uses energy to do a job, using the electricity to turn it into something useful with sound, light, or movement. So here are some examples. A light bulb uses energy to light up. A buzzer uses energy to make noise. A fan uses energy to spin around, and a motor uses energy to spin something to power a boat. Now let's think of a roller coaster on a track. If any parts are missing, like in a circuit, the coaster will never be able to run. So we're talking about circuits, but how exactly do they work? Well, here's the first step. Within the battery, chemicals push electrons out from the negative side, as shown here. Now, electrons want to go from the negative side to the positive side. So they travel through the wires on their way to the load. And this is shown by the arrows from the negative side of the battery. And we can see it goes all the way to the light bulb, which is the load. Now, the load uses this energy. When the electron reaches a light bulb, for example, like here, they give up some of their energy to make the bulb glow. Now, once the electrons return to the battery from the light bulb, they make a complete loop around the circuit by entering the positive side of the battery. So now we can see here that these arrows show that these electrons go from the light bulb all the way from the wire to the battery. Now remember, similar to how we were talking about the roller coaster, if anything is disconnected, the electrons can't finish making the trip, which means no light, sound, or movement can be made. So now that we're mentioning the roller coaster analogy, let's talk about open versus closed circuits, and this example with light. So a closed circuit is when everything is connected and electricity flows and lights turn on. But an open circuit is when something is not connected, like a wire, for example, and electricity stops and the lights turn off. So here is a visual representation of a closed versus an open circuit. So here we can see these yellow little balls are electrons in this picture. And you can see that throughout the circuit, throughout this wire here, they move all the way through. Since this is a closed circuit, this allows the light bulb to light up. But with the open circuit, we can see a part of this wire is missing. A part of the whole representation of the circuit is missing. So that means the electrons can't move back and forth through the positive and negative sides of the battery, which means the light bulb won't be able to light up. Now think of a circuit like people dancing in a circle. So if everyone has to keep moving in a loop, if anyone lets go of someone's hand, the whole dance stops. So here we can see Pikachus holding each other's tails. And this is just like if people were holding each other's hands. So if one of them lets go of someone's tail, then all of this electricity stops flowing. We see circuits in action every day, actually, with flashlights, TV remotes, phones, tablets, lamps, microwaves, even electric toothbrushes. Now, here's a challenge for you all. Count how many things use circuits at home tonight. I'm sure you can find a lot of things in your house. And lastly, here we have some fun facts. So, first of all, lightning is a huge electric circuit in the sky. Isn't that crazy? Here we have an electric eel, and electric eels shock their prey with their built in batteries. And lastly, your body has its own tiny circuits, and yes, you're using them right now. Your brain and heart use tiny electric signals to send messages to other parts of your body, just like how a battery sends electricity to a light bulb. So that's it on how electric circuits work. Thank you so much for listening, and that's it for today.